Greetings, Algebra 3-4. This is for periods 1, 2, 3, 4, 5, and 9. Let's go ahead and take a look at our new section, which is 6-5A, Solving Equations with Rational Exponents. All right, South High Packers, let's go ahead and take a little bit of a review before we get into the main components of this section. If you remember, when we review, I want you all to take a look at this little problem. I've got 64 to the 3 over 2 power. Remember that 3 over 2 is called a rational exponent. That bottom number 2 is your index. That top number 3 is your exponent. So we're going to rewrite it in radical form. Again, that bottom number 2 is your index. So I'm going to rewrite it like this. Bottom number 2 goes right here in the corner, meaning square root. Top number 3 becomes your exponent. So I can say that this square root of 64 cubed. Now you guys all know that the square root of 64 is 8. So I have 8 cubed. And 8 cubed is 512. 8 times 8 times 8, I got 3 of them, is 512. Okay, let's talk about an important concept called canceling rational exponents. What I want to show you here to begin our section is this. I have just the fraction 4/3, and I need to multiply it by something to get 1 whole. So 4/3 times what fraction is going to give me 1 whole? And you all know that the reciprocal of 4/3 is 3/4. So if I write it like this, 4/3 times 3/4, 3 on top, 3 on the bottom, they cancel. 4 on top, 4 on the bottom, they cancel. That's going to give me 1 whole. So this is just a little important piece that we're going to need today for solving equations that contain these little fractions. All right, guys, here's the nuts and bolts. Let's talk about 6-5A. Solving equations with rational exponents. I'm going to go ahead and if you have your notebooks out, let's go ahead and write down this first little sentence. It says to cancel a rational exponent, you have to do the reciprocal on both sides. So for example, I have x to the 2/3 power. That equals 25. If I want to get that x isolated, I want to get x all by itself, I have to get rid of that 2/3. Now I have to do the reciprocal. The reciprocal of 2/3, I flip the fraction. Reciprocal of 2/3 is 3 over 2. So I'm going to put 3 over 2 on both sides. And you can see 2 over 3 and 3 over 2, they cancel. X is isolated. And if I do put 3 over 2 on this side, I also have to put 3 over 2 on the other side. Now, if you recall from the beginning of this little section, 3 over 2, that rational exponent, can be written like this. Remember that bottom number 2 becomes the index. The top number 3 becomes the exponent. The square root of 25 is 5, and 5 cubed is 125. So there's my 125. That's my answer. All right, let's go ahead and solve an equation real quick. So in your notes, if you could write down these directions, solve this equation. Here's my first equation, my first example. 1/10 equals n to the negative 1/2 power. Remember, we want to get n all by itself, so I need to get rid of that negative 1/2. The reciprocal of negative 1/2 is negative 2 over 1, or just negative 2. So I'm going to put negative 2 on both sides because that's my reciprocal. You can see that negative 2 cancels with the negative 1/2, so n is isolated. Now, if you recall from a couple sections ago, Whenever I have a negative exponent, the fraction 1/10 is going to flip around. I'm going to reciprocate it. So the reciprocal of 1/10 is just 10. The negative 2 will become a positive 2, which is 100. So 10 squared is 100. Okay, let's go ahead and do another example real quick. Here's our next example. We have 8 equals 2p to the 1/3 power. I've got a number there. I've got that 2 there. Let's get it out of the way first before we work with that fraction 1/3. So that's 2 times p to the 1/3. Opposite of times is divide. You guys know that we divide both sides by 2. 8 divided by 2, that becomes 4. My 2's cancel. So I have 4 equals p to the 1/3. Now, how do we get rid of that 1/3? Again, we do the reciprocal. The reciprocal of 1/3 is 3/1, or just 3. I'm going to put a little 3 on both sides. 1/3 and that little 3 cancel. 4 to the 3rd. That means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 gives us 64 equals p. Okay, we're going to go ahead and stop there for that video.